Yeah. Everybody sufficiently sleepy after lunch? Good, because I'm going to put you to sleep. Okay, I'm just going to get started. Hey everybody, I'm Ben Plotnick, and I'm going to talk today about dynamic request routing with Envoy. A little bit about me. I'm currently on the PaaS team at Cruise. We're a self-driving car company. But the past few years, I was in the service infra space at Yelp. And that's mostly what I'm going to be talking about, or at least the work that I've done was on that team. So what is dynamic request routing? Let's check the docs. Under dynamic request routing section, it says per request routing, we can, let's see, override the DTAB entries with the L5 DTAB header. This doesn't sound like Envoy. Let's read the previous paragraph. Dynamic request routing is one of Linkerd's more powerful and flexible features. This is awkward. Anybody know where Service Mesh Con is? All right, so neither Envoy nor Linkerd 2 have DTABs, but a lot of this work was heavily influenced by Finagle and Linkerd. So actually, what is dynamic request routing? I think of it as a way to route based on dynamic attributes, which is equally vague. For the sake of this talk, let's make some arbitrary distinctions. So weight-based routing, for example, is where you have like some request, get foo, and you send it to different backends depending on some different probabilities. So you might send 5% to your canary. Let's call this arbitrarily traffic shifting rather than dynamic request routing. Something else might be header-based routing, where you determine the backend based on a header. So in this example, we have this X version header, and we might use the header to metadata filter in Envoy to route based on that header. And this is kind of what I mean when I'm talking about dynamic request routing and dynamic attributes. But again, arbitrary distinction. For the sake of this talk, let's go with it. So let's take a look at something a little bit more complicated. So let's say we have some deeper call graph where we have a front Envoy and then some backend services A, B, and C. And actually, we have Envoy sidecars on each of them. So I've drawn little pink rectangles. And I've logically split up the incoming and outgoing traffic, but it's the same process. And let's say I want to deploy a new version. So it's B canary, and I want to ensure that my request hits that B canary. Or maybe I spin up the version of B on my laptop and I want to hit that version. If I try to just use the X version header like we did in the previous example, this is not really going to work because what is A going to see and what version are we even talking about? So to figure this out, let's take a look at two questions. So one is, how do we shuffle data around to make routing decisions? And two, how do we make routing decisions based on those data? So the answer to the first one of how to push the data around kind of has an answer in distributed tracing, and it's called distributed context propagation. So in tracing, if you've seen Zipkin, you might have seen XB3 trace ID. This header, by contract, every service needs to propagate it from wire to wire across the process. But I think we can generalize this. So we come to our first requirement, which is that we need a generalized way to propagate context. So let's say, for example, that any header that starts with XCTX must be propagated across the process, and we mandate from the CTO that you have to do this. This is a lightning talk, so I'm not going to go into that in any more detail, but there are other advantages to doing this. Okay, so now we can propagate some data, but in order to know what we want to propagate, we have to figure out what we're going to do with it. We need a propagated header to somehow express that, like, instead of routing to X, route to Y. We don't have DTABs, but we can take some inspiration on that. And let's kind of arbitrarily say this is XCTX override. We say we have key value pairs where we say if it's going to foo, instead send it to foo v2. If it's going to bar, send it to this IP. You can imagine something more complex like the DTAB scenario, but this is a start. So we have another high-level requirement, which is we need to be able to parse this XCTX header and redirect the request to a desired endpoint. And let's see what this looks like. This is going to be in an Envoy filter, so get ready for some pseudocode. If you've written a filter or you've looked at any filters, you've seen something like this, which is the decode headers function. And this is one of the places where you can write some code in a filter. So the first thing we're going to do is we're going to parse that header somehow. So we're going to get this map, which maps from where the request was going to go to where we really want it to go now. We need to decide where we're about to route so that we can override it. And then we have to say, okay, if there is an override, then we need to somehow override it. And I'm going to get into what that looks like right now. So let's take a simple example. We have this XCTX override, and we say, a request going to foo, instead send it to like v2. And maybe that represents something like metadata on the endpoint. The override route function could look like this. So inject the new destination where we want to send it to as metadata for subsetting. So this will become a little bit more clear, but basically we propagate some metadata from our filter to the router where there's already functionality in Envoy that does metadata subsetting. But maybe we have some arbitrary IP. So unlike before where we were using metadata to say where we want to go, now we want to actually have a real destination. So it's not a pre-registered endpoint. It's just an arbitrary new endpoint. Maybe this is my laptop or something. Envoy doesn't know about this endpoint, so we need some way to tell it. There is functionality in Envoy that allows you to do this. It's called the original dest cluster, or the original dest functionality, I guess. And we can use this. We could just build right on top of this. So we can inject the Envoy original dest host header. It's kind of long, but it basically says, instead of going to this one place, go to another place. And the way it does this is it kind of on the fly generates an endpoint and redirects the traffic there. And so we have this XCTX override, and now maybe we want to send it to something that's not an IP. It's just like myhost.dev or something, or some like DNS name. And Envoy doesn't know about this. So we can't just use, this is actually kind of like the previous example, right, with the IP, but now we have this added difficulty of DNS. In pseudocode, it doesn't look so hard because nothing does. Okay, this is going to get a little complicated here. We schedule an asynchronous DNS lookup on the thread local event loop. And then we add a callback there that says, when the DNS lookup is done, add the original dest header with the resolved IP. So basically, once the callback is called, it looks exactly like the previous example. When you do this, the request is kind of halted for a moment, but this is generally done by like developers, so it doesn't really matter. Side note, I wrote this filter before the dynamic forward proxy was written. So doing DNS in the request path was not trivial. But I did it. Okay, so now we're able to arbitrarily reroute requests by propagating this override configuration with distributed context propagation, and then use our custom filter that like evaluates this and does something. Unfortunately, the developer experience of sending headers is terrible. If you're working on mobile, you have to use like some proxy. If you're working on web, then you have to use some like extension or whatever. So what we did is we wrapped this functionality in some like sugar. So for Chrome, we built an extension that basically just wraps injecting a header. For the app, we added debug views. So in the debug builds of this app, you could just open it up and add these overrides, and they'll get automatically injected on every request. And then we have CLI support, which is basically just a wrapper around curl. Unfortunately, I don't have screenshots, but trust me, it's worth it to befriend good front-end and mobile engineers. My front-end skills are terrible. Okay, if you're going to do this yourself, there's some things to be careful about. Security, I think any security-minded person here is probably like sweating right now because this allows you to arbitrarily route to like anywhere. So you want to make sure to lock that down. Like we didn't allow this in prod. We allowed like a subset of this functionality in prod. You want to make sure that you're stripping out these headers, pretty much any distributed context at your edge. And you want to make sure that you're not injecting arbitrary data that might like crash your filter. Also, don't write your filter to crash. Actually, when it fails, it's kind of tricky to debug because like it's this weird behavior that you're causing Envoy to like kind of deviate from what it's doing. And the override logic is not trivial to like figuring out where your request is going to go and then overriding that like is not that trivial. Or maybe it is and I just didn't figure it out. But yeah, that's basically dynamic request routing. If you're interested in discussing more about this or about anything, you can reach out to me afterwards or here. Thanks.